sometime this week or next week, you'll have to go over to the bookstore and get the second semester workbook. Okay, it's $5. If you don't have $5, your counselor will give you a coupon so you can get the book for free.
Is there two different, there's two different books?
There's one book for second semester. So we had first semesters, we're finishing, yeah, and then second semester. That we will be starting probably late next week.
Finishing up the first one?
Uh-huh. Because I didn't teach enough.
That's okay. We don't need to.
Plus, I like probability better than other stuff, so I chose to go a little further.
Honestly,
All right. We ready? We all good? Everyone's happy? All right. So, again, I'm on page 87 of the notes. They talk about contingency tables. Okay? Contingency tables are one that they, if you take a look at what they have, they talk about the Atlantic, Pacific, and the Indian Oceans. And they talk about different category hurricanes that happen to be in those regions. Excuse me. So, this is a way when you look at it, these don't have to be in percents. They can just be totals when this one's just totals. So in the Atlantic, it looks like there's a total of 53 hurricanes in this particular, excuse me, in this particular situation. There happen to be 20 that was Category 1, 16 Category 2, 10 Category 3, etc. And you just kind of read it. So if you want to know how many Category 3s were in the Pacific, there were 6. You look at it that way. So they're stating that there happen to be 110 different hurricanes. Of those 110, you had a certain amount in some oceans, certain amount in other oceans. So you're just basically, that's how you just read it. So they say the two variables in the problem can be summarized as ocean and intensity of a hurricane. The data are raw counts, they're not percentages. I have seen these done as percentages, but they don't have to be done in percentages. And they are counts. So we just need to realize that. So let's just take a look at example 1. They say, what's the probability you select a Category 1 hurricane? Okay? So where they're getting the 110 from is that's the total number of hurricanes. That's our denominator. But how many Category 1 hurricanes were there if you look at the bottom of the column of Category 1? And they already gave you this 46, but it's at the bottom. Hey, Chucky, did you have last semester's book still with you? If not, I have copies.
I don't.
Oh, yeah, I made you a copy. Yeah, we're on that front page. So the 46 comes from the bottom column of Category 1, because there's 46. The 110 comes from, that's the total number of hurricanes. So the probability that you know that is 46 out of 110. You certainly could convert that to a percent if you wanted to. Sometimes the percent is sometimes easier to figure out. But basically what this would mean is if I were to put all of these different things, in Atlantic Category 1, I put 20 little things in a cup. And then 16 Atlantic Category 2s, this different color. If we change like different ball colors or slips of paper, if we were to pick out randomly out of one choice, we have a 46 out of 110 chance that when we're talking about the hurricanes, that it would be a Category 1 hurricane. That's how it basically goes. And then each of them, as you go down, take a look at examples 2 through 7. Do you understand where those came from and how those numbers came about? Where it changes is when you're saying or if you look at example 2, select a level 3 or higher. Okay? So you're going to say, I want Category 3, Category 4, and Category 5, which is 18 of them, 11 of them, and 7 of them out of the 110. So if you add 18, 11, and 7 together, you get 36, and then there's the 110. If you're selecting an Atlantic hurricane, there's happens to be 53 Atlantic hurricanes, which happen to be all 5 categories out of 110. Selecting an Atlantic or Pacific, Well, how you get the numerator is you add the 53 for the Atlantic, the 39 for the Pacific, add those together so you get the 92 out of 110. Probability of selecting an Atlantic Category 1 hurricane. So Category 1 in the Atlantic is 20 of them, and there happens to be 110 total for that particular year or season. If you go to example 6, it says selecting a hurricane that is Pacific and less than 3. So if it's less than 3, that means I want Category 1 and 2. And I also wanted to make sure it's part of the Pacific. So you're talking about 16 plus 8. So those are category 1 and 2. So 16 plus 8 is 24. And still there's 110 hurricanes. And then it says selecting a Category 1 or a Pacific hurricane. So that's one that I want to kind of write down for you. So I'm going to look at example 7 so you see how that comes. We want to make sure it's a Category 1 or a Pacific hurricane. Okay, now, are there Category 1 hurricanes in the Pacific listed?
Yes.
Okay, I don't want to count that number twice. So the Pacific Category 1, I'll call it P1, there happens to be 16 that take place. Okay, a Category 1 or a Pacific. So a Category 1, so the Atlantic one, the Indian one, are 20 and 10. So I want to make sure I don't count this twice. If I counted all the Category 1s and I also looked at it and said, and the Category 1s in the Pacific, I don't want to count it twice. So you're going to add the 16, the 20, and the 10 together, and that's going to give you the, is that right? Let's see. Pacific or Category 1. So Category 1, there happens to be 46 total. And then I want to look at a Pacific hurricane. So how many hurricanes? So this is Category 1s. But then if I look at the Pacific hurricanes happen to be 39. But you know that there were 16 that were this. So I'm going to subtract 16 from 39. And that's going to give me 23. So I'm going to add the 23 and the 46 together. This 16 here is the Category 1 Pacific. I don't want to count it twice. So that's where we're going to get the 69 out of 110 probability of that taking place. If I could write, I'd be better at teaching. Again, that's why I round those grades. Okay? So do we feel somewhat comfortable about kind of a contingency table? All right? Let's see. Anyone else show up that I missed? Charlie got here. And Chucky, you know it's open seating, so any seat's open, including the one last comfortable seat. You notice I keep trying to sell y'all on this comfy seat, but there's no takers.
And there's something,
I like bring it to
is
my
there like
desk.
a cast or something?
No, you can't. It has to stay up there.
Sit in the chair and do.
No, because if you put it here, then I can't walk down this walkway.
And Scott sit on my lap.
Oh, man.
Okay.
We just changed things. Oh, jeez.
You're in that. It's first day.
It is. That is true. All right.
Scott's dad is 2-1, bro.
So as we get to example 8, they want, what's the probability a Pacific hurricane will be a Category 5. Okay? So a lot of times they do it like this. Pacific such that Category 5. This means such that. In the statistics world, sometimes they'll write that, and I think it's on the next page. So what they basically do is we want to know what's the probability that's taking place. Okay? So what's the probability I pick a Pacific hurricane that happens to be Category 5? So a Pacific hurricane, there happens to be 39 of them. What's the probability that it is a Category 5 in the Pacific? and there's 4. So I change the probability because basically what I do is this. Let's get away from hurricanes and stuff. Let's break people into hair color. So if I say, hey, all of you who have blonde hair are over here. All of you that have brown hair or black hair are over here. Or everyone who has blonde hair over here, everyone who else has a different hair color over here. Still with me? So then I want to know, hey, what's the probability that a person with blonde hair is wearing a pair of, Nikes? What's the probability that somebody with blonde hair has a pair of Nikes on? So I ignore the rest of the people. I go over to the blonde hair population, which is a smaller population than the entire group. And I say, okay, I'm over here in this group, smaller group. So smaller group is a different denominator than the whole class. Like in this class, there's 32 people. Okay? So if everyone was here, and let's see, I have at least 4 people in here who would have blonde hair. So basically, I'd have the 4 people with blonde hair over here and say, okay, blonde hair people, there's 4 of you. That's my denominator. Who has Nike on? So, I saw Chucky has Nike on because she made sure I knew it. I'm going to change that. So I'm taking the category and I'm taking it. I'm limiting it. So what they're doing in this situation is they're saying, hey, we know we have the Pacific, the Indian, and the Atlantic Ocean. We're going to take the Indian and Atlantic Ocean and forget it. We're talking about just the Pacific, which happen to be 39 hurricanes. And of those, 4 of them were Category 5. So I separated it, even though we had a big group of stuff on there. Uh-oh. Dude. Battery's still good. Still recording? Okay, good. All right. So as I flip the page, you notice example 8 changes to, I went backwards. It said, we talked about the category 5 such that P. So Pacific will be a category 5, so you go category 5 such that P. So that's where your 4 out of 39 comes from. That would take place for any of them. Category 1 such that Atlantic. So again, you go back and you look at Atlantic, saying Atlantic had 53 hurricanes. Category 1, there's 20 of them. So 20 out of 53. So the probability changes when you start breaking the categories. They're individualizing the categories. Okay, and that's what all of those basically go through and do. And then, when should we make a percent? Okay, so there's not always a right answer to this, but I would say make it a percent when this makes sense to the reader. Okay, so you have to know your audience. If you're sitting with a bunch of PhD statisticians, you're not worrying about making things percents. But as you bring down like that real high level of understanding, the percents become easier to fathom. So, if I were to say, hey, 3/4 is 75%, 75% is sometimes easier to fathom than 3 out of 4 times. Okay? So just know that like on a test or a quiz, if you left it as, so let's say you had an answer that came out to 110 out of 203. If you left an answer like this, you're probably fine. If you converted it to, I need another one of these tall boys. If you converted this to a percent, somebody have a calculator? If so, will you go 110 divided by 203 for me?
Divided by what?
203.
4.187%.
So let's say it's 54.19%. So which one is easier to capture the reader's eye? Sometimes the percent, especially if you have it as an article, you would probably keep it as a percent, because if you're writing an article, you don't always know who your audience is. So sometimes this is going to make more sense. So let's see, let me just finish this up. Since probability of hurricane category 5 seems to be lower for the Atlantic hurricanes, this adds evidence to the idea that category 5 hurricanes are less likely for the Atlantic. So they said probability of category 5, it's 7 out of 110, which is 6.4%. Probability as category 5 such that it's the Atlantic is 2 out of 53, which is 3.8%. So the percent changes. So you look at this and it says, some people might say, hey, this is what's going to take place with that. And what we do is you have to be cautious about the data when you're looking at the percents on this. Okay? Next, in the next book, we're going to look at something called the chi-squared test. It's a relatively easy test to do, but it adds validity to information. I know I have told you this before, but when I first came to the district, I taught one period of math. I had my medical class, and then I was a math and a science coach for the district. So I would go to all of the high schools and help any of the high schools who needed help with understanding anything with statistics, or hey, we have a teacher over at Eagle Crest High School that's really struggling with teaching a certain concept. Could you go help that teacher? That was what my job was for my first 3 years in the district. And it was a lot of fun. I missed being in the classroom too much, because I'd walk into a class going, if someone that you had no idea came walking in, it's like there wasn't a relationship that person would have had. And that's how I felt. So I asked if I could be back in the classroom. So they said yes, which I liked. But at Smoky Hill High School, their business department came to me, and their business department said, hey, kids that take our business courses score higher on the ACT than the rest of the school. So they came to me and said, hey, we think our kids that take our business course, any of our business courses, because of them taking the course, they're going to score higher on the ACT. I said, oh, okay. They're like, how can we prove this? I said, okay. I said, well, first, I want to take a look at last year's data. Okay? So they basically, Smoky Hill High School, I'm going to just make up values. Let's say they had 3,416 students. And I'm just making this up. I don't remember what the data was. But the entire school, so all the school, had a certain ACT score. Okay? Whether you took business or not. And then what I did is I said, okay, we see that 700 students take a business course. And so if I just take a look at their ACT score alone, does that show any significant growth? And I did originally show that these kids that took a business course scored higher. Now, was it the business course that had content that allowed those kids to score higher, or was it that you had a more intelligent or more educational environment that took business versus something else? And they were so stoked. They're going, oh, cool, look, we were right. But remember we talked about causation and things like that? There's all kinds of factors that went in. So I said, well, let's see if we can make this happen even more intensely. So last year, before we put anything in place, we already showed there was a little bit higher percent. So then what we did is I created a 5-question ACT practice. Okay, and what each of the business courses did, what I did is I had 2 easier problems, 2 middle problems, and 1 hard problem. And I gave the students, I made a test, they took it. I then had them go through and they would watch my videos and explanations and they would grade their own. And then I had them do it a second time, and then they went and took the ACT. So then the next time they took the ACT, the business scores went up even further. And they're like, oh, cool, this proves it. Well, unfortunately, remember the normal curve? So we had an average here, and you had a standard deviation. So one year would look like this, and then one year it looked like this. So all of a sudden, the standard deviation changed. So it was coincidental that I put something in place, and I actually didn't run a chi-squared test. I ran something called the 2-sample p-test. And the 2-sample p-test gives an R value, which you then take back to the table, and you can use terms like fail to reject or accept. And they had to fail to reject their hypothesis or their null hypothesis, which meant it didn't work. But they were so excited because we actually had a higher average after I put a prescription in, but it didn't prove. And a lot of times what people do is they look at just a simple part of the statistics and say, oh, that's fine and done. We're done with it. Life is good. We're happy. And it's like, no, don't make that mistake. So, hey, how about a whole bunch of homework for tonight? Yeah, sweet. We've been missing this, pal. All right. So, page 209, 210. How about you pick, there happen to be, so I would say, why don't you pick 5 on 209 and pick 5 on 210. Chances are not everyone will pick the same 5. Agree? So if you do that, and again, we'll just be checking off homework like we've always been doing. We will be able to take care of it. What time we at? 9:12? Sweet, we got time. All right. So, are you okay for our first day back?